Hello. Welcome to Calculus in the PM, Part 3 of the Mean Value Theorem, Extrema, First Derivative Test, Section 5.2. Anywho, let's get this rolling. Everybody's with me on this page? So, first thing is to find critical numbers. So, how do you find critical numbers? You do a derivative, right? So, I'm thinking this is x plus 3 in brackets power of a half. I'm not necessarily going to rewrite it because you guys are getting pretty nifty with the numbers. So I'm going to just jump straight to this. What rule do we use? Product rule, and of course the chain rules inside. So the derivative of the first thing is 1. Leave the second thing alone. Now, I'm going to leave it alone as x plus 3. But we understand if you want half, that's fine. Added to the first thing left alone, the derivative of x plus 3 to the power of 1/2 is 1/2 brought down, x plus 3 left alone, the insides are left alone, subtract 1 from that, so negative 1/2. Then the derivative of the inside, in this case, the derivative is just 1, so I'm not going to write it down, but make sure. There's so many times that you have the inside as something like x minus 2 or something like this, that the derivative is 1. When you have something like x squared minus 3, you miss it. So make sure that mentally goes through your head that you're saying, yep, and the inside is 1. Then from there, it's algebra. Is there any question about this part? Okay, that's derivatives. You guys did really well on that test. Okay, so as soon as I see this, I'm thinking I'm going to have to do some algebra because I can't solve this for 0. I can't set this derivative to 0 and make some sense out of it. So I'm going to rewrite it, and I'm going to use a different colored pen as I manipulate, though. You guys recognize that 2 is a denominator? It's on the denominator. And that x plus 3 to the negative 1/2 is the square root in the denominator. Okay? Okay. When it's written like this, I think it makes what you need to do next a little easier to identify, eh? What do you need to do next? Common denominator of 2x plus 3. So I'm going to just use this here. I'm going to multiply the bottom by 2 root x plus 3. But if I do it on the bottom, I gotta do it on the top. Luckily, I can do this. I don't know if I can squeeze it in or not. Forgot to leave the space. So I'm going to erase the plus sign. This times 2 root x plus 3. Squeeze it in, whatever you have to do to make it work. Okay, put it in front of the equal sign, whatever. Squeeze it. Now, you might get to the point where you just automatically jump to that and you do the multiplying right off the bat, and that's fine. I'm not going to assume that you need to. But the next step is, don't ever multiply out, in this case it's not an easy one to multiply out anyways, the denominator. Just keep it factored, right? 2 root x plus 3 on the bottom. But on the top, 2 times, so there's no other plain number, 2. What's root times root though there? It's just the inside. Square root of x plus 3, square root of x plus 3 is just x plus 3. Added to x all over that common denominator. This is algebra, and I know it's been a while since you've done this. Right? You guys all did this? Now you group your like terms on the top, factor if possible. 2x plus 6 plus x, right? 2x plus 6. You guys see what I'm talking about, right? Plus 6, and then add it to that x. 3x plus 6, right? And 3x plus 6, so I'm just thinking this here. Now, if you want to write it down, go ahead. It's going to dissolve there. I could factor that, right? And it's 2 bracket, or 3 bracket, x plus 2. Taint it? Yeah, yeah. 3 bracket. Okay, this is my derivative. Okay. The whole idea, though, is to do the derivative to get a critical number or plural critical numbers.
Use the numerator and denominator, can
Yep, we could do some stuff here. Before I do something, though, I should back up a bit. The original function, the domain of the original function. What's the domain? Can you have a 0 under a square root? Yep. So 0, negative 3 is fine, right? Can you have negative 3.1 though? No, that comes up negative. So the domain would be, whether you want to state it with brackets, interval notation, or you want to state it with greater than, less than. In this case, we're going to just say x is, negative 3 is x greater than equal to or less than equal to? Greater than in this case, right? I'm going to keep that in mind. So if I would have come up with negative 4, for example, as a... Now, if somehow, like right here, if this was bracket x plus 4, and I came up with negative 4 there, could I call that a critical number? No. It doesn't apply in this case, but I wanted to talk to you about that, okay? It has to be in the domain. So the critical numbers here. Setting the numerator or the denominator equal to 0, because the denominator is where it's undefined. We've got two critical numbers here, right? Critical number from the top, negative 2. And the bottom. You can't divide by 0, so you can't have negative 3. Those are the two critical numbers. Now, here's why I want to point out, because sometimes people get confused, but they say, yeah, you can't even use negative 3 because it gives you a 0 on the bottom. This is the derivative, though. It is still a valid critical number because it is actually the very start of the domain. It isn't, the negative 3 is included there, right? It makes sense that it should be. Anyways, okay. We've got critical numbers. Now what are we going to do? We could sub them into the original equation, but sometimes you don't because it turns out that it doesn't even give you a max or a min anyways. But we do a little chart, sign analysis. And that's why I wanted this fully factored here. So my sign analysis now. Draw a little number line, and I put the positive 3, x plus 2, the 2, and the x plus 3. I put every chunk, everything you multiply by separately, so you don't get caught. Now, if you wanted to put 3 halves instead of 3 and 2 separately, I'm fine with that. But you put your zeros then on there, and it does not mean you use the number 0 here. And this is not a number line drawn to scale or anything like that. I'm just putting negative 3, negative 2, putting my critical numbers. I said zeros. But my critical numbers there. Now, positive 3 and positive 2 are always going to be positive, so that doesn't change any size. I'm just going to say that I considered it, though, in case it was negative 3 or something like that. Some people forget that. Now, x plus 2 gives me a 0 at negative 2. If I put 3 or a 0 or anything, negative 1, I get positives here. I double check negatives to the left. X plus 3 gives me a 0 at negative 3. Now, anything to the right, negative 1.5. Still be fine, right? Now, there's something here I did on here. What happens here? What about to the left of negative 3? Doesn't actually exist. We can't include this, can we? Because it's not in the domain. The domain starts at negative 3, right? But it's like it ends. So we don't even consider this stuff. The graph doesn't exist there, but that's the reason why, right? We talked about that. So never worry about anything to the left of the negative 3 now. So sign analysis here. We got negative and positive. Overall, 4 positive things come together. Positive overall. Okay. Now what? This means negative 3 to 2. Remember how I said just get the idea of what I've circled there is the derivatives results. From negative 3 to 2, what's happening to the function? Decreasing. So I'm not worried about curviness, but just to get that idea, I'm decreasing here, then from negative 2 and up, it goes up forever. Now there's going to be some curviness on this. I'm not worried about the curviness though. This doesn't tell me anything about the curviness. Yes?
Does it matter like where the graph would start or anything like that? Or
Well, yeah, like we don't, this could be anything from like this, it could be sort of like, could have been like this, could start way up high. It doesn't tell you where it starts or ends. It just tells you that it increases, or decreases, then increases. That's all it tells you. It doesn't say if it crosses the x-axis or not. Okay, that's just the general idea. But this, right away when I have this sketch here, this tells me that this should be a minimum, right? And this is a relative maximum for that one spot there, right? So, it's an absolute minimum in this case because it never comes back down in negative 2 either. So, we've got a relative min, or no, let's start with negative 3. Local or relative maximum at x equals negative 3. I didn't plug it in. What is x equals negative 3 in that? Oh, it's 0. At negative. I guess I'm saying this backwards because the other day I'd give the ordered pairs, right? It is, I'm saying this in a bad roundabout way. I should probably just erase, but. Okay. I'm saying this totally backwards. A relative maximum at x equals negative 3. I'll just put this in brackets as an aside. Since now, what's our reasoning here? Because usually we say it increases then decreases.
Isn't it because the domain?
Yeah, it's just basically because it decreases after that it starts. Since we could say negative 3 is the first value in the domain, x.
The criteria for being a local maximum is just the points that are surrounding it are.
Yes, are either lower or higher than it, but there's nothing surrounding it on the other side. And I guess we could say f prime of x is negative. On the other side. Now, that was a very poorly constructed sentence and I should have just erased stuff like this. In this case, you're never wrong to just say a local max or local min too, but even better in this case is that it's an absolute minimum, because you could just see from our little sketch there, there's no way you're going to get anything lower than the value at -2. So we're going to say an absolute minimum at, what is that, -2, comma. If I put -2 plus 3 is 1, square root of 1 is 1 times -2. -2 comma -2. I plug it into the original function. It's an absolute minimum at -2 comma -2 since f prime of x switches signs. This is generally the answer you're going to use. Switches signs from, and you can look up at your graph and see why, yeah, from negative to positive. X equals -2. Or at this point, you could say, or something like that. Okay? Now, I'm not going to go through, just for time savings. It does ask for our regions of increase and decrease, but I think you guys can see there, and you know that the sentence is that when it's decreasing on the range from -3 to -2, because f prime of x is less than 0, and then when it's increasing, it's greater than 0, right? I'm just going to try to save the time. Now this, I wanted to do something with fraction exponents. There's really a cube root, and then the other one's a cube root that's squared. So that means we've got to do a derivative, and this is ready to roll. F prime of x equals 3 times 1/3 is just 1 x to the -2/3, so when I subtract from the exponent. Wasn't this set up sweetly? 3/2 times 2/3 with the exponent brought down, so -1 x, and then subtracting 3/3 from 2/3, -1/3, subtracting 1. Okay. Now that's not very user-friendly, but it's our answer. I would suggest, though, and we started the year out working with negatives and with fractions, always factor out your lowest degree. Which is the lowest, -2/3 or -1/3? Yeah, factor that out your first thing. Then we'll worry about putting in the root signs and stuff. I'm going to wait and see what you guys get for this exponent here. Yee.
To the 1/3?
To the 1/3. Ah. Now, do I need to do an aside? When I'm factoring out, I'm going to do this in green here. When I'm factoring out that -2/3, really what I'm thinking is x to the -2/3 is what I'm pulling out. And I'm doing this in green just because it's a thinking step. Now I haven't changed that. That means, let me just see something here. I'll make sure that I get a separate pen here. Okay. Would you agree that what I've written in green there is not changing anything? Because in the bracket, it's still the same expression, and I'm multiplying by 1, right? When you factor, you can think of it as multiplying by 1. And really, I'm thinking I've got to distribute it here and there, right? You guys follow that? And that's where this comes from. So x to the negative 2/3 divided by itself is the 1. X to the negative 1/3 divided by negative, so really subtracting negative is adding 2/3 to that. That's where I get the 1/3, okay? So that's how that works. Now, just so that you can work with this a little better, let's rewrite this with cube root signs and so on. So I'm going to put the negative 2/3 to the bottom. This time I'm going to call it x squared under a cube root. You can think of it as x to the cube root and then all squared as well. Equivalent, I don't care which. Now I'm going to get some space in there. And then 1 minus the cube root. That's just the derivative. I should end the bracket there. I don't actually need the bracket because it's just the only thing on the numerator. Okay, now my critical numbers. Can you see your critical numbers here? Should back up always when you do critical numbers and double check. Is there any domain restrictions here and here? No. Cube roots, negatives or positives are allowed. And there's nothing divided, so there's no zeros that you can't include because they're on the denominator. No non-permissible value. Okay. Can you tell just by looking at that what the factor is? What would give you a 0?
1.
1. Okay. X equals 1 is and what would make this expression? Yeah, 0. Okay. Undefined at 0. And those are both valid numbers to put in here, so they're good. So then what? We go with some sign analysis. The critical numbers marked down. By the way, if this confuses you, this expression here, you could factor out the cube root if you wanted to, and then you'd have 1 minus, or x cubed minus 1. Wouldn't you? Oh, no. Yeah, you wouldn't. No, sorry, my mistake. I was just thinking, it shouldn't confuse you. We'll just go with it. Anyways. So, I'll put in my 0 and my 1 and 1 minus cube root x cube root of x squared. There we go. The numerator gives me a 0 here. Anything higher than that? Positive. No. Tell me. Yeah. This is, remember how I said, don't get in the habit of just putting to the right. I realized as I did the mental check right here. This is one of those cases where the right-hand side actually gives you negatives. This negative, positive. So,
Are you sure?
am I? Sure?
Because if you squared anything.
Yeah, but I'm. Ah! Thank you, kid. What's he saying here? I wasn't looking, I was just looking at the cube root. I didn't even notice I had squared there. Yeah, thank you. What is he saying?
-1 cubed is -1, then you square it, it goes back to a positive.
Yeah. Even my negative numbers are going to come up positive. Thank you, man. It doesn't change signs at all at 0. Good one. I look at my notes here and I have the same, the last time I worked it, I did it correctly. Thank you. Keep checking with me. I make mistakes and they're not on purpose. Okay. Well, something happens there, eh? But anyways, enough about that. It doesn't change. Yeah, there's some kind of thing. There's some kind of thing going on. It's an undefined. Tristan was waving his hands to explain how this could happen.
Yes.
I don't think you had this. Okay, now my drawing isn't quite right, but should have more of an angle. This is what could slightly look. I don't have much curviness on here, right? But this zone is increasing. I should have maybe made it steeper, right? It almost looks like 0. So I should. But there we go. Increasing, undefined here, right? Because it was on the denominator for the derivative. Increasing, hits a 0 here and then decreases, right? That's, without curviness, that's the general shape of the graph. Okay? Good, good, good. Well, we could say the function increases on. What's the interval that it increases on? All the way up to 1. Because we're allowed, if there's no zeros, as long as it never switches signs, right? So, I'm going to do this answer here, and then I'm going to skip some of the other. F of x is increasing on the interval on -infinity to 1. Got it? Since f prime of x is greater than 0 with 1 spot. I guess I should say spot point. If you put spot there or whatever, I'm sure it would accept it. Where is undefined. That's why. And then it's the rest of the answers I think you guys know how to do, right? It's decreasing from 1 and up, since it's less than 0. And the local max occurs at the 1. Since it switches signs from positive to negative, the derivative does. But 0 is nothing. Like it's not a max or a min. Question?
Do we have to state the point when we're stating maximum and minimum?
If they ask for it. Often it'll be just where on the domain is it. There's a maximum at x equals 1 since the, typically it's that, but sometimes you do have to find what's, and then if it says what is the maximum value, that's the y value, the f of 1. If you recall, and this is going back to yesterday, the initial question that these are all based on, find the open interval where it's increasing, decreasing, and the coordinates. And that's why we were finding coordinates. But I don't want to go on, because my voice is going to crap out on me. Let's try this here, and then we're going to turn you loose and we'll have a work class tomorrow. But you'll have a lot of work. We'll do this as a group, though. First column is the function of x. This is the derivative of x. So match them up without the equations.
This was like what we did in the start of unit 3.
Kind of did, yep. So now we're going to try it again here, because you're going to see why in the next section or two why it works, why we really need this skill. So for this section here, by the way, not all of them have matches. What would you say the value of the derivative is? It's the same, but what would it be? Positive or negative? Positive. So the derivative, maybe that's a slope of 1, let's say. Hey? I don't care, like, because these don't have any markings on the axis. But the derivative would look something like this. No derivative here, because it can't be done, but a constant, right? And then the portion to the right is negative If we said the one was positive 1, we'd say it's about the same. It's negative 1 though. Are any of these graphs a match to this? No. Some people will mistakenly say V here. But that's the exact opposite, isn't it? It's a mirror image of what we want, reflected in the y-axis. So that's no good. No match. B. Well, what's the slope like right here? We could say about negative 1-ish. Then what happens, though? The slope here, and then the slope goes negative infinity, really negative steep. Yeah. And then here, positive, but it's steep at the corner right there, right? And then it settles off, maybe 1-ish again, right? Which seems to be a good match for that one? I see a point. Roman numeral which? Oh, come on. 3. This starts off, maybe this is negative 1. Yeah, it's a slope of negative 1. Gets super steep here. So it's a really low value in the negative direction. Really high values, then settles off in 1 here. Okay, this looks like a good match for B here. As soon as you see a linear function, does the slope ever change on a linear function? It's a constant. And in this case on C, positive or negative value? Negative. So you're looking for a line that's below the y-axis or the x-axis, and that's I. That's in this case. So C is a good match with I. Then we've talked about this one in class when we did sines and cosines. Yeah?
Oh, no.
No? Okay. A positive slope may be positive 1. 0, negative 1, 0, positive 1. So which one is that? Yeah, it looks like a cosine. Good. D. And that's how we introduced the derivatives, remember? Of cosine and sine. Just using intuition. E here, it is different than the cosine. This looks more like a cubic function, eh? Like it's not a trig function. So we start out with an incredibly high, but it's not infinity necessarily. We get to a 0, then some negative values, 0, then positive again. So IV, there is a match for this one? Why not?
Because IV only has 1 0.
Also expensive.
Aha! I know it's tricky, but you do see what I'm saying, right? Look at this though, and here's what I want you to notice. Do you notice that this is steepest in the negative direction here, right? At the zero, at the middle. Negative 1 maybe. This is lowest, negative 1 maybe, at that point. And then it starts to get less negative, like, you know, inching back up slowly to 0, inching back up slowly to 0, and so on. So this is a good match for E. It's only the first one that didn't have a match.
And it makes sense that like it's a cubic function.
And that was the next thing. I mentioned it was a cubic. So the derivative of x cubed involves a square. Good. Now, I've asked you to start on some of these. I'm telling you that, you see I've scratched out 44 and I was thinking, you know what, you cover that kind of stuff later on. I feel bad. Well, I shouldn't, but I do. Anyways, now it's not like you don't have to, but try these questions here, okay? And I'm going to just pause or stop.